Yes? Okay. 7.2. We're moving on to addition and subtraction formulas. Addition and subtraction formulas. Okay. Sine of alpha plus beta. You can save it, add them, and apply sine to it. Yes, but I don't have them. I may not have them. And even if I do, I may not be able to find sine of this, but I may be able to find something else. Okay. I'm going to explain right now. So whenever I want to add two angles and I apply sine to it, if I have those angles, I'll add them up and apply sine. But if I don't, for example, there is a formula, and this is what it's called, the addition formula. Sine alpha times cosine beta plus sine beta times cosine alpha. I don't like saying memorize this, but I have to say it now. So there are three identities that we have to memorize. I wish I didn't have to say that, but we do. Okay? So sine of a sum of angles is sine alpha cosine beta plus sine beta cosine alpha. Now if I have minus here, I'm going to have minus here. So if it's a subtraction formula for sine, then I have sine of alpha minus beta equals sine alpha cosine beta minus sine beta cosine alpha. Now for cosine, cosine alpha plus beta, very different from sine. Formula is cosine alpha times cosine beta, but minus sine alpha sine beta. Notice what happens here. If in the middle I have plus, then there is a difference here, which was not the case with sine. If I have plus, then I have plus. If I have minus, then I have minus for sine. But for cosine, signs are reversed. So if I have minus here, then I will have plus here. One more formula for tangent, and we stop there. We don't need more. Tangent alpha plus beta. This is a ratio of tangent alpha plus tangent beta over 1 minus the product of tangent alpha and tangent beta. Last formula for now. And if we have to determine tangent alpha minus beta, the numerator has minus and the denominator has plus. These are not twisted. Tangent is not twisted. Sine is not twisted. These formulas have a lot of applications. A lot. So let's go to page 505. And take it slowly, step by step, all different types of problems. Of course, we're going to have identities to prove as well. So the first identity that I would like to prove before you choose a problem from there is the cofunction identities. I want you to choose. I promised. These are the cofunction identities. Choose one that you want to prove. You want to prove the first one? Okay, so let's prove the first one. So we want to prove tangent pi over 2 minus alpha equals cotangent alpha. Which formula will I use? And if you say the third one, we're going to get into big trouble, but we have to try. Because if we don't see it, we will not understand it. Okay, so the left-hand side, right? So tangent pi over 2 minus alpha equals, according to the formula, can anyone dictate?
Tangent pi over 2 minus.
Yes.
Right.
Right, so this is pi over 2 and this is alpha. So tangent pi over 2 minus tangent alpha over 1 plus tangent pi over 2 tangent alpha. Correct? Where the first angle is pi over 2 and the second angle is alpha. Are we in agreement with this? Is this correct? Do we agree?
Yes.
Okay. Now let's determine tangent pi over 2. And if you remember, you can say to me as an answer, you never told us to remember tangent, and that's true. I only said remember that little chart and remember the points on the unit circle and the little chart. So let's determine pi over 2, tangent pi over 2. We know it's sine pi over 2 over cosine pi over 2. How much is sine pi over 2? It's measured on the y-axis. 1. What is cosine pi over 2? Uh-oh. Right. So I cannot use this. Because I can have undefined minus tangent alpha. What is that? Okay. So we'll go back and try another route. But we had to see it. In this case, if pi over 2 is involved, tangent is no use. Okay, so we're back to the same thing, but the left-hand side is tangent pi over 2 minus alpha. What will be another way? Yes, sine over cosine. Very good. Sine of what? It has to be the same angle. There is no discussion there, right? I can't have tangent 45 as being sine 30 over cosine 30, right? It has to be the same angle. Good. I do have a formula for each. The one that we know from 2 weeks ago, sine over cosine. Tangent is sine over cosine. Okay, now can anyone give us the formula for the top? Yes? Alpha minus sine alpha times cosine pi over 2, correct? So here it is. If this is pi over 2 and this is alpha, sine pi over 2 cosine alpha minus sine alpha cosine pi over 2. Now, can anyone dictate the denominator, please? Cosine pi over 2 times alpha. And then, exactly, pi over 2. Excellent. Very good. Do we all agree with top and bottom now? Yes? Okay. So now, can anyone remind us sine pi over 2? We just used it a minute ago. 1. Can anyone? So this is 1 and this is 1. Can anyone remind us cosine pi over 2?
0.
If cosine pi over 2 is 0, then that term goes away. So then what is left at the top? Yes, or alpha over sine. Good. So what is this? So is this the right-hand side? Done. That's the reason why I had to wait till I presented the sum formulas and the difference formulas to prove that identity. So that these are the cofunction identities. And now if I say sine pi over 2 minus alpha, you will say cosine alpha. If I say cotangent pi over 2 minus alpha, you will say tangent alpha. Secant pi over 2 minus alpha, cosecant alpha. These are the cofunction identities. Sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. Clear? Okay, so back to page now 505. First set of problems 3 to 14. So 3 to 14 on 505. Please choose. I don't want choosing to take so long. Okay. I'm going to, which one?
6.
6.
Okay.
Cosine 195 degrees. Very good. Perfect. Here's the question. Let's read the question. Use an addition or subtraction formula to find the exact value of the expression as demonstrated in example 1. Whatever. Okay. So first of all, I would like to see where this angle is. And find, just to see at least where, in which quadrant it is. It is in the third quadrant. So if this is 180 degrees, then from 180, I need another 15 degrees, right? So this is the angle in question of 195 degrees, correct? Okay. So for now, I'm going to say that this is cosine of 180 degrees plus 15 degrees. I'm asked to find the exact measure of cosine. I'm not asked to plug in the calculator and get 0.9. Good. So now, formula.
We got cosine.
180 times.
Cosine.
Yes. Yes, this is the only one that is twisted.
Minus.
Yes.
Minus.
180.
Times sine.
Very good. Perfect. We don't know anything about 15. We will in a minute. But we do know a lot about 180. How much is cosine 180? Careful. Exactly. So this is -1. How much is sine 180? That's it. This is gone. Good. So then I have negative cosine 15. Now I'm asked to find an exact number or answer for cosine 15. I only know 3 angles. And I have to play with those 3 angles, and I don't have anything else. I have 30, I have 45, and I have 60.
So it would be 30, 45 minus 30.
Exactly. It's not the only way. You can say 60 minus 45. The same thing, doesn't matter. But perfect. 45 minus 30. Excellent. Is 45 minus 30 15? Perfect. So then I have minus outside. It comes from something else. I have to keep it as is. And now the formula. Cosine alpha minus beta. I recommend put everything in brackets because you may forget to distribute that -1 from outside. Don't mess with it just yet. Yes? 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 Excellent. Perfect. Now I need that little chart. So let's start with sine. Let's start with 45. That's the nicest angle ever. Why is 45 the nicest angle ever? Exactly. No, because they are both the square root of 2 over 2. Indeed. Good. So now this is angle 30, which is the first row. First row in our little chart. How much is sine in the first row? First cell. I can never forget the starting point. 1/2. And then it means that cosine must be the other one. That's it. So now I have minus in front. I write everything again. The square root of 2 over 2 times the square root of 3 over 2 plus the square root of 2 over 2 times 1/2. And as we know, in this class, factor simplify, factor simplify, factor simplify. And here's what I notice. That's the common factor present in both terms. I will have minus in front and the square root of 2 over 4. And can anyone dictate the inside? And no one, bless you, and no one can simplify this any further. What is left inside? There are two terms. You cannot stop at the square root of 3. Yes. And we determined cosine of 195 degrees exact. This is the exact number. If you plug in the calculator, it's not going to be an exact number. Okay, are we familiar now with this? We need another one, or we move on to the next set? Okay, please choose. Let's choose another. Which one? Number 10? Very good, number 10. In number 10, we are given cosine 17 pi over 12. Very good. If you ask me to work with 17 pi over 12, I'll say, give me a second. And on the side, I'm going to change pi into 180 over 12. I'll simplify by 6. I'll simplify again by 2. And I'll try to figure out what 17 times 15 is. So this is 80, 7, and 1. Am I correct? I may not, though I don't have. No, don't believe me. So this is 5 and 2. Is this 255? Am I correct? Yes? Nobody wants to check anything. Good. I can get away with anything then in this class. Is it true? So I simplified by 6. So that's 30 and 2. And then 15. Is 17 times 15 255? Okay, perfect. Just making sure. So if this is 180 and this is 270, 255 is 15 shy of 270. Would you agree? So we are talking about this angle. So this is the 17 pi over 12.
So we use the reference angle 180 as a reference angle?
You could.
It doesn't matter which one.
It doesn't matter. No. I'm not really looking for the reference angle right now. I'm looking to use two angles like I did before. It's a very good question, actually. So, for example, here, I could have used 270 minus 195, right? So I mean 270 minus the rest till 195. But 180 was closer. I wasn't looking for the reference angle here. I'm only looking to find two angles that I add or subtract that will give me this 195. And because 180 was closest in this case, and I knew that something will cancel out because at these points, either sine or cosine is 0. One of the two terms will go away anyway. So even if you refer it to 270, one of them will still go away because either sine or cosine would be 0 there. So again, we're not looking for the reference angle here. If we were looking for the reference angle, yes, of course, I would have said 255 minus 180 is 75. We can refer it to 180 if you want to, or to 270. Let's do it with 180. That's fine. So this is cosine However, I have to present it in, if you want, you can continue cosine 255 and then say cosine 180 degrees plus 75. That's fine, but you still have to, once the answer is first the answer will be a number. It doesn't matter if I use angles or radians. Okay, so then the next step would be, exactly. And we know that sine will go away because sine at 180 is 0. So this will be cosine 180 times cosine 75 and minus sine 180 sine 75. How much is cosine 180? Careful. We are on the left-hand side, right? So it's -1, so this is -1. So it's been negative cosine 75 degrees. Because sine of 180 is 0, and 0 times sine 75 will be 0. Then I'm back to cosine 75. I reduced it to something I know. And now I have 3 angles that I can play with. That's really all I know. So now this becomes negative cosine of very good. So now I can determine cosine 75 degrees exact. So what is the formula? I will put it in brackets so I don't forget to distribute that if there is a need. Okay, so I have cosine 45.
Where's the negative cosine? So we cancel that out, that's 0.
Cosine 180 is -1. Cosine is measured on the x-axis, and at 180 is -1. This.
And then how do you, on the right-hand side, you get negative cosine 45 plus 30.
So there is no left-hand side and right-hand side. They're all equal.
Right, well, I'm just saying that, like I'm pointing out how do you get that side.
-1 times this is this.
Okay.
This is 0. 0 times sine 75 is 0.
Right.
So I have -1 times cosine 75, which equals -1 cosine, and instead of 75, we write this. Then we use the formula. Cosine 45,
Cosine 30.
cosine 30, yes,
Sine 30.
yes. So now that's the reason why, that's one of the main reasons why I asked you to memorize that little chart. So which angle you want to get rid of right away? Yes, because it's the same. And now I have to think. It's 30 degrees again, and sine 30 is the first cell, which makes it, which makes this one the other one. So then I have the square root of 2 over 2, the square root of 3 over 2, minus the square root of 2 over 2 times 1 over 2. Factor is the answer here, and I will remove these. So I have minus the square root of 2 over 4, and please tell us the parentheses. Good, but it's minus. Good. Let's move on to 15 through 20. We are here asked to use an addition or subtraction formula to write the expression as a trig function of one number and then find its exact value. So we are looking at problems 15 through 20, please. 16. So let's look at 16. Let's copy it. Cosine 10, cosine 80. Cosine 10 times cosine 80. And then minus sine 10, sine 80. Exactly. It's cosine 10 plus 80, which is cosine 90, which happens to be exactly. Perfect. Okay, let's choose another from the same set and then continue. So one more time, I want to go back to our syllabus. So here's what we are still working on 7.2, but I am hoping that you are going to look at all these problems. There is a lot of work here. There is a lot of work here. Okay, so please, for Wednesday. Okay, ready? Please choose the next problem. Okay, 18, I'm sorry, which one?
20.
Okay, 20, perfect. Okay, so 20, cosine 13 pi over 5, 13 pi over 15 times cosine negative pi over 5 minus sine 13 pi over 15 and sine negative pi over 5. Good. Is there a formula that looks like cosine, cosine minus sine, sine? Which is?
Cosine.
Yes. So it's cosine of what?
13 plus.
Exactly. So it's minus pi over 5. Very good. So cosine alpha plus beta. I have to find the least common denominator. What is the least common denominator of 15 and 5? 15. So this one needs a 3. So the top will be 13 minus 3. 13 pi minus 3 pi, which is 10 pi. I'll simplify by 5, and I get 2, and I get 3. So this is cosine 2 pi over 3. I'm asked to find the exact value. Now I need the reference angle.
What's the weight there?
I hope we are not having difficulties in fractions. Please. Okay, very good.
Right.
As fast as I talk. I know. I've been accused of that before. Tell me something new.
Question.
Yes.
When did add addition?
Yes. Alpha plus beta. You cannot change the sign on this.
Oh, okay.
It's still alpha plus beta.
Okay.
Because it's minus here. So it's alpha plus beta. So now I need a unit circle and I need to find the reference angle. Where does 2 pi over 3 land? In the exactly in the second quadrant, right? It's 2 of 60 degrees and this is 180 degrees, right? So I have to be right here. Now I need the reference angle. What is the reference angle? Exactly. So now I have to think, what is the sign of cosine in the second quadrant? Perfect. So this is minus cosine pi over 3. Pi over 3 is at the bottom of the chart, and cosine is not the first column.
Okay. So why would you use the reference angle right there? Is that because we're 80 degrees?
The reference angle is always the angle formed between the terminal side and the x-axis.
Yeah, but why do we use it this time instead of previously?
Very good. Here, in the previous case, I was only trying to find two angles whose sum is 255.
Okay.
I wasn't at that level, at that stage, I wasn't trying to find the exact answer.
Okay.
I was only trying to find two angles whose sum is 255.
Okay.
So, but when I'm trying to find exact, then I have to use a reference angle. So then, cosine is the second column, and pi over 3 is the last row. What do I have in the second column, last row?
It's 1 over 2.
Exactly. It's exactly what I have. No. It's exactly what I have in the first cell. I have in the last cell. 1/2. with minus in front.
Negative.
That's it. So the negative comes from the fact that it's in the second quadrant, and I had to establish that. That's why I needed to see where it lands, where the terminal side is, so I know the sign of cosine. I needed to determine the reference angle because now I was ready to find the answer. Okay, moving on. Prove the cofunction identity. We just did. We just did 21 through 24. You can do that on your own. Let's prove some identities. 25 through 42. 25 through 42. Let's look at a couple of identities and prove them. Okay, if you don't want to choose, I'll choose 34. In 34, we have cosine x plus y plus cosine x minus y. They say it equals to cosine x cosine y. Now let me draw your attention to something that I sometimes see. We know that it will be a terrible mistake if I would write something like this, right? This will be horrible, right? Have to find the least common denominator, which is a product of 2 and 3. It's not 5, and so on and so forth, right? And then I multiply the top by 3 and the top by 2, so this is 3 plus 2, so the answer is 5/6. I can't do any of that. It will also be terrible to say that cosine x plus y equals cosine x plus cosine y. This will be terrible. I cannot distribute the function to a sum of two angles. So when I see something like this, cosine of a sum of an angle, I have to remember the formula. It's cosine x, cosine y, minus sine x, sine y. So as terrible as this would be to write 2 over 5, this is exactly as terrible as this one is. So I know that we are seeing it for the first time. Don't ever assume anything that we haven't done together. So please, cosine x plus y is like cosine alpha plus beta. You cannot distribute. Okay, is that clear? So I will start with the left-hand side. I will write cosine x plus y plus cosine x minus y. I have to write the starting point, and then I apply the formula twice. Once on the sum of the angles and the second time on a difference of angles. So what do I have to write for the first one? Cosine x cosine y. Yes. Sine x sine y, and then plus x cosine y, and this time plus sine x sine y. And I notice something. These two go away, and the answer is done, right? 2 cosine x cosine y, and it equals the right-hand side, and it's done. So please don't fall into that trap of thinking that you can distribute cosine to a sum. You cannot distribute cosine to a sum of angles. Okay, so let's choose another.
So we choose the formula because they call it the most cosine.
Every time I see a cosine of a sum or cosine of an angle of a difference, I have to use the formula for the sum or addition or subtraction formulas. Yes. Ready? Let's look at 45. In 45, we are asked to simplify this. Sine of tangent inverse x minus tangent inverse y. And you can look at this and say, oh, I remember it's problem 5, similar to 5 that I forgot to do on the test.
All right.
Instead, you could say, this is way more difficult than that one. because there is a sign outside and I have a difference. But I know something that I just learned about sign of a difference. But these must be what in order to apply that formula? What must these be? Right. Are they angles? Of course they are angles because tangent inverse is applied to a number and the answer is an angle. Excellent. I am going to call this alpha and I am going to call this beta. So I am going to write the formula first so I can see it on paper. Assuming that this is alpha and beta, which formula will you dictate? Sine alpha times
Cosine.
beta.
No, minus.
Yes?
Sine beta.
Yes?
Cosine alpha.
Excellent. So now I will take the alpha aside, and I have alpha equals tangent inverse x, and I will stare at it for a second, and something will come to me. The only thing that can come to me, and the only thing that I can do is, yes, the answer is not that.
No, it's 1 over 8.
So if you go back to the problem that we just did from the test and look at it and see what we did an hour and a half ago. Exactly. That's the only thing I can do. There is nothing else. So then tangent alpha equals how much? Right. And then I'm going to think of a right triangle with an acute angle alpha. And I know something about its sides. If I know that tangent alpha is x or x over 1, then I know something about the sides of this triangle. Therefore, I can determine the hypotenuse. So the hypotenuse is the square root of? Excellent. Perfect. Now let's come back here. And we know what we are trying to determine or asked to determine. We know about angle alpha. We don't know it about angle beta yet. So please give me this piece.
So 1 over
Careful. Opposite. You said opposite. X over?
1 square root 1 plus x.
Excellent. So this is done. But you will also give me this.
1 over.
We have 2 more pieces to discover. So now I have to go back to angle beta. And I know that beta equals tangent inverse y. Okay, now what? What is the only thing I can do here? So then tangent beta will equal? Good. So then I have a right triangle with an acute angle beta. And I know something about its sides. What do I know about its sides? So I know that this is y and this is 1, correct? Then I know that this is 1 plus y squared with a square root, which cannot be simplified, correct? So then I know this piece. Can anyone give us this piece?
1 over 3.
Good. And now can anyone give us this piece? Exactly. So now finally, I have the whole thing. X times 1 over the square root. So x divided by the square root of 1 plus x squared, the square root of 1 plus y squared. And minus y times 1, I'm going to put it at the top. And this is it. Because the denominators will be the same for both. Say it again.
Do we have to rationalize?
It's a very good question. No.
Okay, so that's our answer?
That's it. Allow me to send a test to Hawaii.
Somebody in Hawaii?
Yeah, somebody is, I'll show you. Somebody's taking, and I send it to myself. Somebody's taking a test tonight, and I'm sending it to, I want to forward it. Okay, so I'm sending this to these two, the testing center. For what did I say? What did I do there? Okay. Thank you. Cut. That's it. Thank you. Because she's taking it at 7 o'clock. It's 1 o'clock p.m. over there. Okay. Ready?
So I have a question with that.
Yes.
The formula for sine, so that's the one we use for this problem, correct?
Yes. Sine alpha minus beta. Sine alpha cosine beta minus sine beta cosine alpha. Okay. Any questions so far? Okay, so 7.2 reaches till including 41. Nothing beyond that. So I also showed you one more example of that. Okay. We want to practice or we continue?
Can we do like
Yes.
one more?
Yes. Oh, by identities? Of course. Yes. Yes.
Can we do 36?
Yes, 36. Let's take a look at 36. 36, I see it. Cotangent x plus y, they say equals cotangent x, cotangent y minus 1, divided by cotangent x plus cotangent y. Perfect. Okay, so any suggestions? Where will you start?
The right-hand side, that looks complicated.
I will definitely start with the right-hand side. Very good. So if we start with the right-hand side, perfect. Then I will change cotangent, but I prefer writing it for everyone to see first. Cotangent x plus cotangent y. So first up, I will write cosine x over over sine x times cosine y over sine y minus 1 over cosine x over sine x plus cosine y over sine y. Now what?
Please comment at the end.
Yes, we have to find the LCD for top and bottom. Perfect. What is the LCD for the top?
Sine cosine.
Correct. And the same for the bottom. Sine x, sine y, sine x, sine y. Adjustments for the top. Or can anyone give us the top?
One needs sine.
So first, yes, it's sine.
So one needs sine y, one needs sine.
So I have to write cosine, cosine,
Oh,
cosine x, cosine y. And yes, you're right, I have to multiply by sine x, sine y. So I will write minus what?
that whole thing.
Exactly. Sine x, sine y. Perfect. What about the denominator? What does the first one need?
Shouldn't be cosine x and then sine y.
Yeah, that's out.
Yeah,
You mean here?
No, it's top.
The top, yeah. Cosine
It's
x.
sine x, so cotangent is cosine over sine. Cotangent is cosine over sine. So this product is sine, sine.
Right, but in your equal, you have cosine, and on the top of that, you have cosine.
Yes, cosine x, cosine y is this product. I cannot disregard it. It has to be here. I have to start with the top of the first fraction.
Yeah, but aren't you putting sine x with cosine y and sine y with cosine x? Like when you multiply through?
But this is a product.
Oh.
This is a product. This is not a sum. So this is cosine x, cosine y over sine x, sine y. This is not a sum
Alright, I got
or a difference. This is together. One.
I got you. Yeah.
One
They're
product.
separated.
Okay. Yeah, because I had the product here.
Mhm.
Yes, maybe I should have written the fraction first and then. Okay, sorry about that.
No worries.
I see.
Is it clear now?
Yeah, it makes sense.
Okay, perfect. So now the denominator, what does the numerator of the first fraction need?
Sine y.
Sine y. And what does the other one need?
Sine x.
Good. So now can anyone dictate the top of the bottom fraction?
Cosine x, sine y.
Yes, I'm going to start with sine y, cosine x. It doesn't matter, it's the same thing. Plus,
Plus cosine y.
yes, if you always want to keep them in the form sine, cosine, then always keep them like that so you are able to easily identify the identities. So now I know what this is.
Oh, that's cosine x plus y.
Indeed. Over this times, and I flip, sine x, sine y. And now what is this?
That is cosine. I mean, that's sine.
Yes, sine of
Wow.
plus
X.
or x plus y. What goes away?
Sine x over.
Yes. And please remember it's 1, not 0. So what I have now is cosine x plus y over sine of x plus y. And I can always look to the left-hand side and see where I'm going. So what does this mean?
That means tan of cotangent. I guess that.
Which is the left-hand side. And it's done. There is only one more section with identities, and then the last two sections from chapter 7 deal with trig equations. And that will be the end of chapter 7.
We just test after that.
I'm sorry?
We just test after that instead of including chapter 4.
Chapter 4 is not difficult. Chapter 4 deals with the two new functions, but you will see the variety of applications in real life situations.
Okay.
Chapter 4 deals with almost anything that you can think of, like population growth, like bacteria, mice, radioactive decay. The mass of a radioactive substance decreases in time based on a function that is in chapter 4. When you put, since Thanksgiving is coming up, when you take the turkey out of the oven, its temperature will decrease. using a function from chapter 4.
Oh, that's cool. Yeah.
When-
Did I learn that before Thanksgiving? So I can
Yes.
It's like to get home, like,
Yes. And even very sad situations when somebody dies, the person's day and time of the death is determined with a function from chapter 4.
oh, interesting.
It's maybe one of the most interesting because it has so many applications in real life situations. It's not going to be a difficult